So hi, in today's lecture we are going to see that how to find a unique element in an array. Okay, so here they are giving us this sorted array, okay, in which every element is duplicate. Okay, only the one element will be not duplicate. That means we have to return that element. Okay, now I hope you got the question. So here in this case we have to return 20 because 20 is not duplicate. Now the first and the foremost approach will be the brute force. Okay, so here we can just take this element, okay, and try to check whether that element is present in an array or not. If it is present, that means the value 2 is duplicate. Okay, so over here if we take this element and try to check over here, okay, we didn't found any element which is 20. Okay, so here we can say that this element is unique. Okay, now the thing is that over here, since we know that the array is sorted, okay, so taking this element and searching over the entire array is stupidity, because here we can see that this element will be obviously present just beside that, right, over here or over here, right, because it is a sorted. So why can't we just compare the adjacent element? Okay, so in this case we can optimize this approach, okay, just comparing this adjacent element, and that's it. Okay, so starting from 0th index we can just compare with this, then we will not go over here, we will just move one step ahead. That means from 0 to we will be going to 2, then over here, then over here, then over here, and so on. Okay, so we are just comparing over the adjacent element. So by doing this, okay, the time complexity of this approach will be order of n only. Okay, so the for loop, sorry, the code will look like this. For I will be coming from 0, I should be less than n, I plus 2. Okay, and here we are going to check if a of I is equals to a of I plus 1. Then we can just move forward, but here what I'll do, I'll just twist a little bit. So I'll just write not equals to. If that's the case, then we will simply break the loop, or else we can just simply return a of I. That's it. There are some minor changes that you have to do, but I believe that you got my approach, that what does this mean. Okay, so over here the time complexity will be order of n and the space complexity will be order of 1. Okay, so again I'm telling you, okay, over here, okay, there should be a different condition. Okay, but I believe that you got my point, so you have to figure it out what will be the condition over here. Okay, now let's talk about the second approach. Okay, so in the second approach, what we can do, we can just have a hash map, okay, in which we will be storing the frequency of each and every element. Okay, and then we can iterate on the hash map and just try to check whether any value is actually having a frequency of 1. If we found that value, we can just return it. Okay, so simply have a hash map in which, in this, we will be having a frequency of each and every element. So 2 is actually having a frequency of 2, 8 will be having a frequency of 2, 11 will be having a frequency of 2, 20 will be having a frequency of 1, when 25 will be having a frequency of 2, and then 37 will be having a frequency of 2. Now we will not iterate on the array, okay, we will be iterating on the hash map and just try to check which element is actually having a frequency of 1. If we found that, just return that element. Okay, so first create an hash map. Okay, now using for loop, here we will be iterating on hash map, okay, not an array. So depending upon the languages that you are using, you can just try to write it in your own language. Then check if the value is equals to 1. Okay, because this is the key and this is the value. Okay, if the value is equals to 1, return that key. That's it. Now talking about the time complexity and the space complexity of this code. See, creating an hash map, that means storing that value inside the hash map, will take order of n time. Okay, and iterating on the hash map will also take approximately to n time only. So the time complexity will be order of n, and the space complexity will be also order of n. Okay, approximately to order of n. Now again we have to optimize this. Okay, so what can be done? So let's come to the approach 3. Now talking about the approach 3, here I will be using the XOR. Okay, why? See, in XOR there is a property. If we have, let's say, element 3 and we want to do the XOR with 0, the answer that we will be getting is 3 only. Okay, so we have to do it bitwise. So it's 0 0 1 1, and the binary code for 0 is 0 0 0 0, and if we do XOR we will be getting 0 0 1 1. Okay, I believe you know the truth table of XOR. 0 0 will be giving us 0, 0 1 will be giving us 1, 1 0 will be giving us 1, and 1 1 will be giving us 0. Okay, so that means if the same values are there, the output that we will be getting is 0. Okay, and if the inputs are different, the output that we will be getting is 1. Now if we take 3 and do XOR with 3 only, the answer that we will be getting is 0, right? Because here in every case the inputs will be same only. So 0 0 1 1, 0 0 1 1. Okay, if we take bitwise, the inputs are same, so 0 0 0 0. Okay, so keeping this thing in our mind, if we take this 2 2 8 8 11 11 and then 12. Okay, now we have to do XOR of all these numbers. Okay, if you do XOR with 2 and 2, the answer that I will be getting is 0. Okay, then I have to do XOR with this 8, so the answer I will be getting 0 XOR 8 will be 8. Again I have to do XOR with this 8, the answer that I will be getting is 0. Then I have to do XOR with this 11, the answer that I will be getting 0 XOR 11 will be 11. I have to do this XOR with this 11, so the answer that I will be getting 11 XOR 11 will be 0. And then the answer, again I have to do XOR with this 12, so the answer that I will be getting is 12. So if we think about it, so if we observe, these are duplicate, these are duplicates, and these are duplicates, right? Only 12 is not duplicate, and if we do XOR we are getting answer as 12. Okay, so using this approach we can also solve this problem. So the code will look like this. For I will be coming from 0 and it will be counting n, then here initially the answer will be 0. So answer, shorthand operator XOR equals to A of I, and that's it, we are done. So at last simply return answer. Okay, so talking about the time complexity, here we are only having a simple one for loop, so the time complexity will be n, and we didn't take any extra space, so the space complexity will be 1. Okay, now the thing is that, see, here we can see that the array are sorted, the array is sorted. Okay, so can we apply binary search over here? Let's see. So the approach 4. Okay, now this is a data set, and let's say here I'm giving the indices. Now if we observe, okay, the first occurrence of every element is at even index, okay, till of till the unique element, okay, and after that the first occurrence of every element is at odd index. So keeping this observation in our mind, can we apply binary search? I mean to say, see here, low, high and mid. Initially the low is 0, the high is 10. If we calculate the mid, it will be 5. 0 plus 10 divided by 2. Now if we talk about a of 5, okay, the value present at a of 5 is 11, okay. Now we have to search, basically we have to think whether this value is not equals to before that and not equals to after that. If this is a case, then we will be getting the unique element, okay. So the first thing will be, we have to check if a of I minus 1 is not equals to a of I, and a of I is not equals to a of I plus 1, okay. If that's the case, then we have to return a of I, sorry, a of mid, okay. I'm so sorry, this will be mid. So in short, I am writing m, okay, m, okay. Now let's say if we found out that here in this case, okay, this 11 is actually equals to the previous value, okay. So we have to make our mid over here, because this is the first instance, okay. So if this is the case, if a of mid minus 1 is equals to a of mid, okay, then we have to make our mid equals to mid minus 1. Why? Because we are searching that unique element in terms of first occurrence, okay. So now we will be checking, see, initially the mid was here, okay, because of this. Then I will be checking whether this element is equals to this or this, okay. I got to know that this value is basically equals to this. So the first is false, okay, but the second is true. So I will be marking this mid over here. Now I will check, mid is pointing to index 4. That means it is a even number, okay. So in this case, I got to know that till this point, I didn't get any unique element, because the mid is pointing, the first occurrence of that element is pointing to even. So I need to search on the right hand side. Got my point? So if mid mod 2 is equals to 0, okay, if this is the case, then I have to search on the right hand side. So I will be doing low is equals to mid plus 1, okay. Now think about it, should I doing mid plus 1 or it should be mid plus 2? Because till this point I got to know that the unique element is not present. So instead of putting mid over here, okay, I will be doing mid plus 2, okay. But if this is not the case, if this is a else, that means the mid, the value mid is at odd index. So our unique value is present on the left hand side. So do high is equals to mid minus 1, okay. So I believe you got this. I'll be putting it here and let's try to dry run this, okay. Now I got to know that a of 5 is 11. Okay, so mid is will be here. Now I'll check. This is equals to 11, right? So I will be putting mid is equals to 4. Now check, is mid even number? Yes, definitely it's a even number. So I will be putting low is equals to mid plus 2. Okay, so I will be making my low to mid plus 2. Okay, so the mid is 4. Okay, so 4 plus 2 will be 6. High will be as it is. 6 plus 10, which is 16, divided by 2 will be 8. Check. A of 8, here in this case it is 25. Okay, now again check the first case. Here we can see that the first case is failing because this 25 is actually equals to the previous one. Now since it is equals to previous one, okay, so this case is passing. So I will be making mid as 7. Okay, after making mid as 7, I will be checking whether mid is even or odd. Here in this case it is odd. Okay, since it is odd, so I will be doing high equals to mid minus 1. Now high will be mid minus 1, that will be 6. Okay, low will be 6 again. Now checking the mid, it will be 6. Check. A of 6, which is 20. Now we will be applying the first case. Here we can see that for this it is not equals to the previous and not equals to the after value as well, right? So we will be returning 20 and we will be getting our answer. That means our unique value. Okay, now talking about the code, the code will is pretty simple. See, first of all we have to have a while loop in which low will be less than equals to high, right? After that we will be calculating the mid. Mid will be low plus high whole divided by 2. Now we will be having our first if case. If a of mid minus 1 is not equals to a of mid and a of mid is not equals to a of mid plus 1. If that's the case, then we have to return a of mid. Right? Again we will be checking, not again, if this is not the case, then we will be checking a of mid minus 1, sorry, minus 1 is equals to a of mid. Okay, in this case I will be doing mid equals to mid minus 1. Okay, because that will be the first occurrence of that element. Now check what is the mid, if it is even or odd. Here in this case the mid is even. Now if it is even, then I have to go on the right hand side. So low is equals to mid plus 2. Otherwise, else high will be mid minus 1, because I have to go on the left hand side, and that's it, we are done. Now talking about the time complexity. Okay, before talking about the time complexity, what if this is the case? See, 1 2 2 3 3 4 4. Okay, in the first go only we got to know that the element is different. Okay, so because if the elements are duplicate, the the element present on the 0th and the 1 will be same, right? So can't we just write it over here that if a of 0 is not equals to a of 1, so simply return a of 0. Similarly, it will be here also. Let's say 1 was present here and 5 is present here. So here in this case also we can see that this 4 and 5 are not equal, right? So that means the last index and the second last index are not equal. So here in this case also we can check then and there. So why to waste time? If a of n is not equals to a of n minus 1, so I'll simply return a of 0 and over here return a of n. That's it. Okay, now this will take constant time. Okay, but what about this? Here we can see that we are applying binary search, okay, in which every time it is dividing by 2, so the time complexity will be simply order of log n. And space complexity, it will be order of 1. That's it. Okay, I hope you got this. This was a bit trickier part. Okay, it's hard to come up with this approach, but yeah, that's it. And that's it from my side. I'll see you in the next lecture. Till then, keep practicing. Thank you.